Alright, guys, let's try to answer questions based on organic chemistry. Alright, which of the following structure represent ketones? This is a bonus because it's this one. Why? Because the double bond is in the middle. The double bond between oxygen and carbon is in the middle. Therefore, the answer is C here. Okay. Which of the following formula below represent alkane? Okay. Remember, we said it's gonna be N to determine the problem is H now. The problem is H now. It's gonna be N times 2 plus 2. You remember that? Okay, let's try to test that. If we are saying 2 times 2 is 4, therefore this is not, because we have to add 4 again, because arcane 2 times 2 is 10. This is incorrect. 14 times 2 is 28 plus 2 is 30. So this is the answer. So the answer is this one. Okay, this is 2 incorrect. Okay, so the answer is C again. Okay, hope you follow that. Consider the organic compound below. Okay, then the IUPAC name of the compound is, okay. Remember the roots. Let's count to get the what do they call the parent name. If we count from here, 1, 2, 3, 4, 4, 4. Okay, the same thing. Okay, therefore, if we count from this side to that side, where are the branches? If we are saying this is a parent name, this is a parent name. The closest end that has branches at this side, because if we're counting from here to here, we get the branches. But from this side, it's too far to get to the branches, so we need to count from this side. So, okay, we're gonna have the branch at this and the branch at this. So the branches are on the same carbon. So this answer would tempt us. This answer would tempt us. What are those branches? It's methyl and it's methyl. Do you have to double methyl? No. Hence, you have to have a di. So it's still a methyl. What is this chain? Is butyl. It's butane. So this is also, this is the answer. This has to be a correct answer. So the answer is C again. Okay. I hope that made sense. Oh, this is not what we are dealing with at the moment. This is not what we're dealing with at the moment. This is not what we're dealing with at the moment. Okay, let's quickly check on the solution of what other guys are saying. Okay, so the answer is C, C, C. Okay, as we said. Okay. Let's try to go to question 2. That's what the method is. A test tube containing a straight line chain. They are saying it's a straight line chain. Okay, organic acid C, which is this one. Okay, we don't know what it contains. Ethanol. This is ethanol because it's alcohol. This is a crew. This is the reason we're saying it's an alcohol, because it's H and O plus a catalyst. Okay, so let's think about this. I didn't teach you this part, guys, but let's think about it. It's alcohol plus carboxylic acid. Where are we getting? This has to be an esterification process, and we have to get to an ester. The result has to be an ester. Alright, the catalyst here has to be acid, I think, in the presence of acid, and the heat here is it's what? It's an, okay, whatever it is. Okay. Let's go to the answers. Compound Y is produced according. Compound Y has to be in any case an ester. Has to be an ester because your reactant was carboxylic acid plus alcohol, so it has to be an ester. Has to be an ester. Okay, but we don't know how many carbons, hydrogen and carbon here. But the question will give us what that is. Give a reason why the test tube is heated in water but instead of directly over this I will get the what the solution is, but I would normally think that the system is frameable, meaning it can burst. It's I wouldn't be too sure of the answer here because it's too general and it needs someone who's specializing in physics. Write down the type of reaction that takes place here. The types of reaction. How many reactions do we have? How reaction do we have? We have addition reaction. We have elimination. We have substitution. I would say this is a substitution, but I'm not sure because we haven't dealt with this. I would say this is a substitution. Okay. I would say this is a substitution. Is it a substitution? We have added something and we ended up. I would say the substitution, even though I'm also tempted to say it's an addition, but an exact answer is the fact that a process or is an esterification. Okay. Formula of the catalyst needed, or is gonna be, they call it sulfuric acid. It's gonna be sulfuric acid. We're gonna see on the solution. We also already talked about this because it's an ester. Halo gas series to which this compound belongs to is an ester. Okay. The molecular mass of compound YS. Okay. And its empirical formula is this one. Okay. Determine the molecular formula of Y. Determine the molecular formula of Y. Okay. We haven't dealt with this one, so even this one will depend on that one. We haven't dealt with this one, so we'll just skip this part. Okay, write down the structural formula of organic compound of this. Write down this. Okay, since you'll be having this one, it's gonna be easy to come up with the acid, if what that acid is. Okay, let's quickly go to the memo. I was still gonna teach you this part because it's not part of organic chemistry. It's a question that has been taken somewhere else. Okay, so let's go to the solution. Let's go to the solution. Yeah, as I said, it's a flammable, so it's easily catch fire. Yeah, can catch fire easily. It's flammable. The substance, alcohol and ethanol, because even if you can try to have a heat against alcohol, and the entire house, if that is in the house, is gonna burn, has to burn because the alcohol is flammable. Okay, there are more answers that are given there. You can go. Okay, the reaction. Okay, the reaction, it was esterification. Condensation, it was esterification. Okay. As I said, and the the catalyst that it has to be used, it's sulfuric acid. This is the molecular formula of sulfuric acid. Okay, and the homologous stores those was an ester, as I said. It was supposed to be an ester, and here they try to go to a molecular mass, from a creatine molecular mass, and they divide the two, and they get up the coefficient to be 2. Then they have to multiply the entire compound by 2, and that is your ester. This is your ester. All right, so if you have an ester, it's easy to determine your acid. If what was that acid, okay, because if you added an alcohol, then to all right, okay, if you since you know that compound X reacted with ethanol, and we know that from ethanol we have 2C, and if we can subtract 2C here, we'll be left with 6Cs, meaning the acid has to have 6Cs. Right, that would be hexane, but it's an acid, hence it's gonna be hexanate, or whatever you pronounce it, the way you are comfortable with. Okay, why is it called ethynyl? Okay, why is it called this? The reason for this is because when you name an ester, you start with an alcohol. An alcohol is ethanol. It's ethanol. So instead of saying ethanol hexanol, you would drop that NOL, and it would become ethanol. Ethyl hexanate. Okay, that's what it is. That's what it is. Okay. Then drawing a structure of an acid, it has to have 6's. Okay, 1, 2, 3, 4, 5, 6. But it's an acid, then we have to have alcohol here, and then a double bond of oxygen and carbon, and everything else it's what we normally have. Okay, so that's what it is, guys. Okay, let's go to do question 3 and see how far can we go with this question. It's a boiling point question. It's really boring because I've been yet reached this part, but it seems like we can answer this one. Okay, define what boiling point is. Okay, whatever it is. Okay, we don't have time for that now. Write down the name of functional group of this compound. The name of functional group of this compound. What is this? It's carboxyl group. So it's carboxyl group. This one. What is this? Oh, hence it's 1 micro. It's carboxyl group. So it's carboxyl group. Okay. Name. You pick name of compound C. Where's compound C? This one. Let's count C's. It's 1, 2, 3. So it's propane. Okay, but it's an acid, so it's gonna be propanoic acid. Hence it's just 2 marks. There's no need to consider branches and so forth in this case. It's not complex because propanoic acid. Write down structural formula of functional isomers of B. Where's B? Okay. They are asking you to come up with it yourself. Structural formula. We have 2 C's here. So whatever that you are coming with has to contain two C's. Okay. And you have to think about that. You have to, and then you draw a structural formula for this one. Okay, because we've been drawing this thing. Okay. The focus is that on C you have to have a double bond, and on the same C you have to have an alcohol group attached to that. That's all that you have to do, and it's just 2 marks. Okay, we'll see on the solution if what they have. Which of the following compound they are taken to boiling point and so forth? We're not interested on that part for now. We'll do that at a later stage. Okay, they are still interested in boiling points. Okay, we're not interested. Primal and secondary. Oh, okay, let me just explain this now because it's a bit easier. Okay, primal, secondary, and tertiary alcohol. Here you consider carbon. Okay, if the alcohol is attached to, okay, let me illustrate this here. Primal, secondary. Okay, if you have this compound and you have alcohol here, this is going to be secondary alcohol. Why? Because the carbon that is bonded with alcohol has a bond with two carbons. This carbon and this carbon. So you only consider carbon. What if there was another carbon? It would be tertiary because the carbon that is bonded with alcohol, which is a subject of interest, is bonded with 3 carbon. What if this alcohol was here? It's gonna be primal because it's bonded. The carbon that is bonded with alcohol is bonded with only 1 carbon, which is this one. Then it would be primal. But if it's here, tertiary. If it's the carbon is bonded with 2, then it's secondary. If it's bonded with 3, tertiary 1, then it's primal. Okay, let's go back to what we've been doing there. Let's quickly go to a solution for the parts that we have answered and just ignore the parts that relate to the carboxylic group, as I said, and propanoic acid, as I said. Then there would be the structure of P, okay, as I said. Okay, the boiling point thinking, we don't have much interest on it for now. Primal alcohol is gonna depend now because the bond was at, okay, alcohol group, which is OH group, is bonded to a C bonded to another C atom. That was their reasoning. Okay. This is pretty much crazy. Okay, let's go to question 4. Okay, question 4. We have this botanate plus this one. Okay, what is this reaction? We're saying this plus this on the reactant. Okay, we haven't dealt with reaction as yet. Okay. To find this, you have to go and find the definition yourself. The reaction will deal with the reaction at a later stage. Give the structural formula isomers of this one. 2-butanoate. Okay, meaning they are saying you can draw this either way. Okay, let me try to do that. Structural isomers of butane. Bromo butane. Okay, structural isomers, we can say, okay, then drop C here, then you have butane here, then you're done. That is the structural isomers because number of C's remain the same are 4. This is butane. This is structural isomer, but the original one was like this, and this was your protein, and it was like that. But the structural isomers of this one, you still have the same number of atoms, but the structure is different. Hence, we are saying it's isomers. Okay, this is exactly the same as this one, but the structure is not the same. Hence, it's called to be an isomers. Okay.